Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a concept of total drag force on a flat plate due to laminar and turbulent boundary layer. So for the laminar boundary layer, actually we have discussed the drag force, but for turbulent we need to discuss in details. So to discuss the total drag force exactly for the turbulent boundary layer, we need to consider the laminar boundary layer also. That's why I have written here the total drag force on a flat plate due to laminar and turbulent boundary layer. So here, if you see, this is the plate what we have considered here, and this is the part what we have considered the plate part, and the fluid is flowing with a velocity of uniform velocity, or we can say that is capital U, with a velocity it is flowing over the plate. And as we have already seen previously, there is a boundary layer formation will be there, and in the boundary layer formation we have the category of laminar and transition turbulent, and that is due to the Reynolds number and the value of x, or you can say the value of a, which is nothing but the distance from the leading edge. So this is the plate and this is the leading edge actually, and the plate is fixed and with a length of L, and these are this is the transition period, and up to this length the laminar boundary layer exists, or we can say this is the laminar zone, and after that turbulent zone will be transition zone, then it will be started, turbulent zone will be started. So these things already we have discussed. So now the concept is first, before calculating this one, we need to consider a flow over a flat plate. So this is the flat plate what we have considered here. So this one you can write, this is a flat plate. Okay, so in the flat plate we need to consider, as I told you, this is the length L and this is the A, the distance, the laminar boundary layer distance from the leading edge. So L is the total length of the, you can say L is the total length of the plate. So that what I have written here, the total length of the plate. And similarly, we need to consider this is the A. A is nothing but the length of the boundary layer. So A is the length of laminar boundary layer. Laminar boundary layer. And similarly, though we are considering this is a plate, so obviously it will have some kind of width also will be there. Like suppose if you draw any kind of plate, it will have a width like this. Okay, so this one, if you draw, obviously this one I can consider this is a width of B. So now here let me write B is the width of a plate. Width of a plate. Okay, now if the length of transition region, see, if the length of transition region to be assumed to be negligible, that means we know that there is no certain discussion about transition, because it is the period only from laminar to turbulent. So if this is negligible, then from where the turbulent will be started? Obviously the total length is there, and what is the laminar boundary layer zone? So that will be the length of turbulent boundary layer. So what I can write here, if I minus total length minus the length of the laminar boundary layer, if I write this one, then I can say the remaining part is the length of what? Turbulent boundary layer. I hope you understand. So this is the length of laminar boundary layer, and total length is L, and obviously the total remaining length will be the turbulent boundary layer if the transition region is negligible. Transition region is negligible. Okay, then we can consider the total length of this was, that is turbulent boundary layer. Now what we need to calculate here, we need to calculate the drag on the flat plate. As I told you, we need to calculate the drag on the flat plate for the laminar and for the turbulent boundary layer. Okay, so that need to be calculated. So it need to be started from the leading edge. This need to be started from the, obviously from the leading edge need to be started, and we need to assume that what we can assume here, like the drag on the flat plate of laminar as well as the turbulent boundary layer, and the assumption that to be the laminar boundary layer starts from the leading edge. Obviously this is the, like, it should be started from, like, laminar will be started from the leading edge. That is the assumption need to be considered, not from the some other points. Okay, so and this will be valid when laminar boundary layer is negligible. Okay, now thing is that first of all, previously we have seen already laminar boundary layer. We have already calculated what is the bound drag force is there for this. That one already identified. Now to calculate the turbulent boundary layer, what we need to do? We need to start from here. Now, as I told you that we need to consider from the leading edge. That means what we need to consider? The laminar boundary layer should be negligible. If turbulent boundary layer will be calculated from the leading edge, then obviously what we need to assume that laminar boundary layer is negligible or very, very minimum. But we can see the length of this laminar boundary layer is some length is there here, okay, which is not negligible. Okay, so the total drag force, so what I meant to say, as I written here, the total drag force need to be calculated. So the total drag on the plate due to laminar and turbulent boundary layer, and turbulent boundary layer will be calculated, first point of what I can write will be calculated. First one, we need to find the length of the leading edge up to the laminar boundary layer. First one, we need to calculate the length of laminar boundary layer, like up to what length the laminar boundary layer exists. So that we need to calculate. Let's calculate this. So we know that how to calculate this one based on the Reynolds number. Okay, so we know that Reynolds number equal to and rho u x by mu, and Reynolds number value is, we know that for this condition we need to consider this is 5 into 10 to the power 5. So obviously your density of the liquid and velocity will be given and x will be calculated from here. So if you calculate the x value, then it will be this one divided by rho u. So x will be calculated. Now this x value is nothing but here a. Okay, so a is calculated by the Reynolds number. Okay, so that means laminar boundary layer length was calculated. Now the second point is we need to find the drag. We need to find the drag by using Blassius equation. In the previous videos I had told you like what is Blassius solution, and we need to find out the drag by using the Blassius solution for laminar boundary layer of length a, or nothing but x, that what I have taken here. Anyway, that x and a both are, we can consider as same. So we need to find out the drag by using the Blassius solution for this laminar boundary layer over length of a. So that is second point. The third point is we need to find out the drag. And here due to turbulent boundary layer. Okay, see here we have calculated for the laminar boundary layer. Now here drag we need to calculate due to the turbulent boundary layer for a length a only. That means for this length we need to calculate laminar boundary layer, and for this length we need to calculate the turbulent boundary layer. But when we calculate the turbulent boundary layer, that time we need to assume that the laminar boundary layer is not existing or that is negligible. Okay, and finally what I can write, then finally we can find out the drag due to one. Okay, first one calculated, second one Blassius equation, laminar boundary layer, third one is the turbulent boundary layer, and no, actually this one drag due to turbulent boundary layer we can consider for whole length, not for this one. First one we can calculate for not for the a, for the length of total length of the plate, so that is nothing but L. Total whole length we need to find out. Okay, and then find the drag. Here we can write find a drag due to turbulent boundary layer, over a length for a length of A. Anyway, same thing, like I can write this one to upper and this one, that line I can write in the down. Anyway, both are same. Drag due to the turbulent boundary layer for, here we can calculate for a length of A. That means for this one. Okay, so for the total, as we have discussed, the total drag, how we can calculate the total drag on the plate, because both we need to consider, laminar as well as turbulent we need to consider. So here, how we can calculate? Now first one, the drag, first point, the drag given by which point? Blassius formula. So drag given by point number 2. Okay, then second one, the drag given by point number 3. The drag given by point number 3, and the next one, that is here. If you see the fourth point, the drag due to the turbulent boundary for a length A, so that is here, see, that is already we have included here, so that need to be minus here, so we can minus this one. So drag given by point number 4. Okay, so these two, now see, drag given by the point number 2. Point number 2 is what? Now that is the drag Blassius equation, laminar boundary layer for a length. That means this one, what is the drag is there for this laminar boundary layer. Then total, like turbulent boundary layer for the length from here to here. Then already we have taken, again we are calculating this one, so we can minus this one. So that minus means the drag due to turbulent boundary layer for a length of A. So that one I have done negative minus here. So for this we can write the total drag over the plate equal to, so drag, we can write drag, this is due to laminar boundary layer over a length, what? This is A, starting one, A, then this is plus, then that what I have written, just to put the value here, put the equation here, that is drag due to turbulent boundary layer, this is turbulent boundary layer over a length L, and final one minus the drag due to turbulent boundary layer for a length A. Okay, so this is our final equation. Okay, so based on this we can calculate the total drag on the plate for laminar and turbulent boundary layer. So I hope you understand this concept. This is simple, but thing is that we need to consider some assumptions, as I told you, and along with that we need to consider both, like turbulent and boundary layer for whole plate, and we can calculate this one. So I hope you understand, and this formula already I've given you previous lecture. I have shown you the formula for this. Only the concept need to understand here. So I hope you understand. Still, if you are having doubt regarding this, you can give a comment on the comment box. Thank you.